GD5 Pilot with you out at the Hillsboro hangar on a Thursday, and I'm out here doing the work that I want to on that wing to install the angle of attack sensor as well as the magnetometer, which does require cutting on the wing. And as you know, that's when I get nervous, when I cut aluminum on an aircraft. So what I've done is made sure I've leveled the aircraft with a water line, and then side as well as laterally made sure that I am completely level. And then how this angle of attack sensor has to work is I need to be at 60 degrees pointing down, which basically ends up being coming back 30 degrees from the horizontal, and mark that area on the wing. And then I marked it, made a cut, and then I used a step drill bit to just gently ease that up to a larger size so it's big enough for the rivet that the Van's RB12 kit uses to be the sensor that acts like a pitot. And as I get a higher angle of attack, more air comes through that pitot than does through the airspeed pitot, and it compares the differences and calculates what my angle of attack is. And as you can see from the kit here I have, that's a pretty good size head on that particular rivet. That's the one that they found works. So I can hold that up against there and see that, yeah, I've got the sizing correct. And you're asking yourself, okay, now what are you going to do? You drilled the hole too big for the rivet. Well, how the hell are you going to mount that? What I'm going to create is a backing plate that comes in from behind. So this will be, the rivet will be mounted into a 32 thousandths piece of aluminum that I have conformed to match the curve of this wingtip. And then this will be mounted into that, where I can make sure I get the rivet pulled to the correct depth, drill that centerpiece out, because I don't want to pull the rivet the whole way through on that installation. And the other side of this is where the little flexible line hooks up to act as the line that I use for the pitot. And then two more rivets are going to go to both sides of this. That'll be pro-sealed into place. We'll hold that into place and act as securing this rivet in the correct location, and then it's just a matter of getting out and calibrating everything once they start flying the aircraft. Now, I'm sure you might be asking yourself now, hey, that's great. How exactly are you going to get inside of that wing to do all this magical work you're talking about doing? So to explain that, that's going to require that I climb underneath the aircraft and show you. So now I'm underneath the wing, and let me show you the next thought. So underneath the wing, I've marked where the magnetometer will fit, and then the size hole I'll need to create so that I can have the doubler and make that work. The other thing I have to do is this can't have any ferrous material, anything that would conduct magnetism. So I can't use the normal riv nuts or the rivet plates, but the nut plates. So what I'm going to have to do is fabricate my own out of aluminum and tap them and use a stainless steel screw to hold this in place. But before I do all of that, I'm going to cut the hole out for this and then make the cover plate, the access plate for it. But before I put that doubler and backing plate in, this gives me a large enough hole I can get in and access through the holes in the spar up to where that is, and I can get the pitot mounted and installed. So this part goes in first, and then I have the line running through the wing, and then I can access all of this afterwards and finish that installation up. On the other side of the wing here, I've got to set the EMU11 right about where I'm going to have it in the wing, but you can see I've got the spar marked out with the measuring tape, so I'm staying well clear of the spar. And the spar, of course, at this stage actually has the holes in it, the lightning holes that allow me to get the wire to pass through there. But why would I pick this location? This is the furthest location on the aircraft that I can find where I'm not going to run into other electrical or magnetometer problems. The wingtip out there has metal on it and some bolts, and I need to stay 3 feet away. And then the other point that has some potential for trouble is possibly right there. That I'm not sure if that one had some screws in it, but I'm 3 feet away from that as well. I know this one is riveted in. That's all aluminum construction right there. And I know I have more metal back up in here. So this is all aluminum where the fuel filler is, so I don't have to worry about that. But that's the farthest in a BD5 you can get away from potential magnetic interference. Obviously didn't want to put it in the fuselage because there's just all kinds of opportunity for the drive system, the gear system, the flap system, all of that could give me some signals in the engine. I'm sure would put all kinds of signals out. As much as I wanted to finish this job on the wing on Thursday, got delays, and I'm back here Sunday finishing up, and let me show you what I figured out for finding what level would be. Now that Garmin GMU 11 has some pretty tight tolerances. You need to be within, I think, 3 degrees of level and straight ahead. So the ribs on the wing are actually aligned very well with the fore to aft dimensions, but I've taken and set up a little laser level here and then made the marks on this template I made, so I can take and get some measurements, and then I have to extrapolate that into how far up into this direction I need to go to make that mount, since the mount itself is going to be probably attached to that access plate itself. I may attach it to the rib. I'll see when I get the area open which I prefer. But the part I'm happy to report is both of my dimensions for the fore and aft markings on that little template are correct. So what that gives me is a figure that I took home and put into my computer with SketchUp Pro, and then drew a little template up, which this thing should be showing you right about now. And I was able to get the dimensions I need to make the aluminum part that would fit into there. And now the next part is taking the wing off. I've already got it started. Got that access plate off, and always nervous about this task. But look at how when you've got the wing supported correctly, this just glides out very nicely. It's all a matter of making sure everything's aligned so you don't gall that aluminum. And now the wing rests nicely in the little cradle I made. I'm going to go ahead and pull the other wing off because some of our next task is going to involve running the wires down through that tube once I get the this little access plate all finished and manufactured. All right, both wings are now removed. I'm going to put a little safety cover over the spar on the fuselage itself to keep it from getting bumped into. And boy, I tell you, Brian Ingram's trick of putting the STP oil treatment really does work well. It stays in a nice state where it doesn't get sticky, doesn't dry and cake, and then cause you all kinds of trouble with pulling that off. So happy with that job, and happy for the suggestion Brian gave me. All right, now I've got the hole opened up, the edges deburred, and pretty much straightened out to make a nice looking access plate. You can see my lightning holes in the spar itself, and that one to the right is going to line up with the pitot for the angle of attack quite nicely. Now I know the dimensions. Now I need to make the plate that I can be able to fit it down through there, and that of course has to be attached to the flexible line that RV12 specifies for that. So I'm going to finish cleaning this up, start working on the access plate itself and the little piece for holding the GMU 11 in place. All right, I've got the 2 pieces of 25 thousandths cut, marked, and drilled, and then now use that as a template to set that on here. That'll hold what ends up being the cover, the access plate itself, as well as hold the backing plate, the doubler that goes behind there, and then provides the cutout. And I'm going to get this prepped, but I'm not going to install this right now because I want this wide hole here so I can access and get down to making the part that also is going to create that pitot angle of attack system. So now I've got the doubler, basically the backing plate to that access hole, drilled, clecoed into place with the 3/32, and we're going to pull those clecos out. Next, I'm going to put the actual part that's going to be the cover plate into those same holes. Since I've drilled those exactly the same, we'll use it to scribe out the dimensions of the actual access plate, and then we'll come back, put this piece on, take the measurements I need for the cutout hole, and then go to work making the holes larger, and then doing the countersinking so that we have to dimple die them so that the flush rivets will fit in correctly. So now the cover is scribed, so I can cut that out, finish that piece up, make my marks 3/8 of an inch in on this piece so that I'm ready to make the little backing plate for it. I'm also going to drill these out to 3/8 so that they're ready for deburring and dimple dyeing. And there's the access plate, all trimmed to those dimensions. So that should be a nice, really good fit. And I marked it on this side as to which is the inside and which side points toward the flap, which side points towards the spar. Now to get on with the marks on the backing plate. So there it's drilled to 1/8, and it's marked for where the access hole is going to be. Getting ready to pull that off, deburr those holes, run the dimple die through both those parts, and then cut that inner piece out, and then we'll go to work on where the countersunk screws are going to go. Those will be stainless steel, and then I have to actually mill the aluminum nut plates for that, so I don't have any ferrous material in there. And the cutout's marked out, but making sure I've got the dimensions that allow that GMU11 to drop right through that little slot. Okay, so those are dimple dyed now, and the access hole is cut out on the backing plate. So now they'll go to work on marking the holes for the cover itself, and then get to work with that fabrication, and then also cut this piece out before I install that. So there, have the access plate drilled. Initial 3/32 holes in. Now I'm going to up drill that to 1/8 inch, and that's basically ready to get ready to make the nut plates, which that'll be some fun. And of course, I'm still remembering to make that first. Well, there's my crazy idea. I took and cut 1 3/4 round piece, then curved it to match the profile there. How did I do that? I held this tool up against getting the profile that I needed, and then held it against that piece to get the shape I needed, and then figured out where the center would be, and then drilled a hole, put a screw that wouldn't mess up the number 30 drilled opening there, and then fish this down into there, and then through trial and error worked the 3 drill points out to put the rivets in to hold that into place. So now when I clean that up, I'm ready to get into a little bit of Pro Seal, get these pieces in. I'm going to start messing with the rivet out of the RV12 AOA kit to see if I can get that in, and then make sure I have a way of fishing that down through those little holes to get down there to that spot. I'll talk about being just right. I've got the rivet in, and this basically ready for doing an install. There's the clear plastic tubing that runs through the wing, and I've fed that through, and yeah, that's what I've got left. So I have just the right amount to get this part to work. I'm going to go get some RTV and leave this setting up, because this really needs to have a good seal on it. So I'm not going to get to do the rest of this install. It means I won't be doing the finishing this up either today, but I'll be back here this coming Thursday, hopefully, and the following weekend to finish up this interesting wing part. Well, I'm hoping you all enjoyed today's video, and I'm going to leave you looking at the new panel running in demo mode again, because yeah, I like watching that myself. BD5 pilot's out for now.